Greetings from K.S.Rangasamy College of Technology. This is Dr. S. Muthukumar, Assistant Professor from Department of Mathematics. In this video, I am going to explain about the nature of quadratic form. So, what is quadratic form? So, a homogeneous polynomial of the second degree in any number of variables is called a quadratic form. That means all the terms involved in that expression should be of order 2. So, here the examples are given in 2 and 3 variables. In the first equation, it is a quadratic form in 2 variables. There are 2 variables, all the terms are occurred in power 2. That is x square plus 4 into x power 1 into y power 1 minus 5y square. Then the second example is for 3 variables. In that expressions, there are 3 variables available. Then matrix form of quadratic form. Each canonic quadratic form can be converted into a matrix form, which is equivalent to x transpose A into x, where A is a coefficient matrix which is symmetric. Then x is the variable vector, column vector, and x transpose is the row vector. So, matrix form of quadratic. So, this is the general form of matrix quadratic equation. So, here consider the quadratic equation. Ax square plus by square plus cz square plus 2hxy plus 2gyz plus 2fzx equivalent to xyz. That is row vector, variable vector xyz, then matrix A, symmetric matrix. So, first row entries are x square coefficient A and the second entry xy coefficient divided by 2. Here the xy coefficient is 2h, which is divided by 2, that is h, and the third entry is the coefficient of x and z. So, x and z coefficient 2f, which is divided by 2. The second row entries are the coefficients of yz, y square and yx. So, the first entry coefficient of y and x, that means 2h divided by 2. Second one is the square term, that is b square, and third one is the y and z, its coefficient 2g, which is divided by 2, that gives the answer g. Similarly, we can formulate the third row, and the last one is the transpose vector x, y, z. So, the second example is given for 4 by 4 matrices, that means quadratic form in 4 variables. Next, nature of quadratic form, index, signature and rank of quadratic form. So, we can classify the given quadratic form into different categories. So, the first one is positive definite. So, if all the eigenvalues of a matrix correspond to the given quadratic form are positive, means it is known as positive definite. If all the eigenvalues of the matrix A less than 0, that means negative values, means the classification of quadratic form is negative definite. So, the third classification is positive semi-definite. If all the eigenvalues of A are positive and at least one of them is equal to 0, then it is positive semi-definite, and the next case is negative semi-definite. That means all the eigenvalues are negative and any one of them is equal to 0, then it is negative semi-definite, and the last case is indefinite. That means the eigenvalues of A are in both positive and negative. So, these are the 5 different classifications of quadratic form. Then we can calculate the index, signature and rank of the quadratic form. The respective formulas are: the first formula for index, it is denoted by p, small p. So, p is the number of positive eigenvalues of A. So, in order to calculate the index of the quadratic form, it is enough to find out the positive eigenvalues of A. And the second one is signature, it is denoted by small s. Small s is the difference between the number of positive eigenvalues and the number of negative eigenvalues. And the last one is the rank of quadratic form. Rank of quadratic form is same as the rank of A. That means number of non-zero eigenvalues. So, these are the classification and index, signature and rank of a quadratic form. So in the problem we have to find out the signature, index, rank and nature of the quadratic form. So the given quadratic form is 8x square plus 7y square plus 3z square minus 12xy plus 4xz minus 8yz. So in order to find these terms, first we have to formulate the symmetric matrix corresponding to the given quadratic form. That means matrix A. So now form the matrix A. So the diagonal entries are the square entries of 3 different variables. So that means the given expression is quadratic form in 3 variables. So the resultant form, that is matrix A, is of order 3. So the diagonal entries are square entries 8, 7, 3. Then the remaining entries in the first row, that means second entry in the first row is the coefficient of xy. Here the coefficient of xy is minus 12. So minus 12 to be divided by 2. So the second entry minus 6 and the third entry coefficient of x and z. Here the coefficient is 4 which is divided by 2. So that means the third entry is 2. Also the matrix corresponding to the quadratic form is symmetric. So we can write the first column as the first row. Here the first column entries, remaining entries are minus 6 and 2. So then we have to find out the third entry in the second row. That means coefficient of y and z. Y and z coefficient is minus 8. The term should be divided by 2. That is 4, minus 4. So we can replace the same value for the second row, second column and second entry. So this is the required quadratic matrix for the given quadratic form. Now we have to find out the eigenvalues for this matrix to find out rank, index, signature and check the nature. So the characteristic root of A is given by determinant of A minus lambda I equal to 0. It is used to find out the eigenvalues of the matrix. After replacing the A matrix and lambda value and 3 by 3 identity matrix, it is equivalent to 8 minus lambda minus 6 2, and the second row minus 6 7 minus lambda minus 4, and third row 2 minus 4 3 minus lambda. After taking the determinant of this one, we can get the equation lambda into lambda minus 3 into lambda minus 15 equal to 0. Then solve it. So which gives the values of lambda. So these values are the eigenvalues of the matrix A. That means roots of the characteristic equation are the eigenvalues of the matrix A. Then based on these eigenvalues, we can classify the nature and can find the index, signature and a rank value. Now check the eigenvalues. Here the eigenvalues are 0, 3 and 15. So there are 3 eigenvalues, 2 are positive and 1 is equivalent to 0. That means all the eigenvalues are positive and 1 is equivalent to 0. So its nature is positive semi-definite. Then P value, that is index value. P is the number of positive eigenvalues. There is non-zero eigenvalues. Here there are 2 non-zero eigenvalues, 3 and 15. So index P equal to 2. Then signature S. S is the difference between number of positive eigenvalues and number of negative eigenvalues. Here there are 2 positive eigenvalues and no negative eigenvalues. So difference is 2. Then rank of quadratic form, which is equivalent to rank of A, that is equivalent to number of non-zero eigenvalues of A. So here the number of non-zero eigenvalues 2. So the nature is positive definite. P, S and rank values are equivalent to 2. Then come to the second example. Here also we have to find the nature, index, rank and signature of the quadratic form. As discussed in the previous example, we have to formulate the matrix A. So take the diagonal entries are the square entries, then remaining entries are the coefficients of combination variables and divide it. So the matrix A is 1 1 3 1 5 1 3, 1, 1. Then find out the eigenvalues by using the formula determinant of a minus lambda I equal to 0. After taking the determinant, the eigenvalues are minus 2, 3, 6. So using this value, we can find the remaining values. That means rank, index, signature and the nature. Here there are 3 eigenvalues, one is minus 2 and the remaining are 3 and 6. That is, one is negative value and the other two are positive. So the eigenvalues are in both positive and negative. So its nature is indefinite. Then p value, index, number of positive eigenvalues, which is 2. Then signature, that is difference between number of positive eigenvalues and negative eigenvalues. There are 2 positive eigenvalues and 1 negative eigenvalues. So 2 minus 1 equal to 1. Then rank of quadratic form is the rank of A, number of non-zero eigenvalues. So all the eigenvalues are in non-zero form. So the rank of quadratic form equal to 3. Then there are some example problems are given. So in the first problem, we can find the index, signature, nature and the quadratic form. And the second one is we have to formulate the quadratic form corresponding to the given matrix. Okay. So these are the concept of eigenvalues, quadratic form, nature, index, signature and also etc. Thank you.